factor analysis is also one of the powerful tools that you need to be equipped with, especially if you really want to be a vibrant analyst. You need to know it. It's important for you to know factor analysis. And then, like I said, I talked about other tools like we have discussed, regression and a few others. It's also important for you to know the prerequisites for using factor analysis. Not that you just wake up one day and say, wait a minute, I think, let me use, which of these methods can I use for me? I think, I like because you like. No, not because you like, but because your data, have the qualities or the prerequisites that is expected of what you intend the analytical tool you intend to use. So we're going to begin to see it now. So what is factor analysis? A correlation-based data reduction technique. It is a correlation-based data reduction technique. If you look at that word, data reduction. Factor analysis, apparently, the aim of factor analysis is to reduce our items into sizable numbers. Items is talking in terms of maybe you want to decide and say, wait a minute, I want to see how many items, which items. Take, for example, you want to measure maybe the rate of death or mortality rates of, I think we call it maternal mortality. For example, you want to measure that. So there are a number of factors or a number of items you may have to pull together to be able to confirm what is likely to be the causes. What else? It could be their height as well, which you measure. Their size in terms of are they obese or not? In terms of talking about their body mass index, are they normal? Are they normal in terms of their BMI? Is their BMI normal within the normal range and things like a number of items that you can pull together to now decide, oh, wait, I think we can deduce from what we have found that this is what is likely to be causing this. Now, when you have a list of those items to decide the cause of that maternal death, a list of them, like say 16 or 20 questions that you want to ask your respondents. Say, for example, you ask them about their age, that's an item. You also ask them about their diet. You ask them about what they take in the morning, what they like to take, especially maybe in their third trimester. What do you normally take? You take fatty foods and things like that. So that's also an item. It could also be multiple items. So by the time you sum up those items together, it could be run up to 16 or 20 items to take a decision. So what factor analysis will do for you is, that's what they call it, a data reduction technique. It's a technique because you cannot report 20 items. Take, for example, you have 10 minutes to now report all the things you have gathered about pregnant women. You are now saying item 1, we ask them question about the job of their husband, and then 2, we now move to the second question, and then we ask them about their age, and then 3, the third item, we ask them about their body mass index. In fact, we even measured that, and we found out that this person was this number, this person was normal, that one was obese. You cannot be reporting it item by item. So what factor analysis will do for you is to bring all these items together, take it to the computer, and ask the algorithm of factor analysis to compare those variables. We call them items in factor analysis, done. To compare them and then bring a summary for us in terms of reduction in the size of items, in the number of items that has been measured. You get the argument? I'm talking about, you have like 20 questions or 25 or 24, whichever number you have itemized on your questionnaire. Don't forget, you are coming from your questionnaire. Your questionnaire is the first thing you will do to present to your respondents, and they have completed it. So now you have keyed in your data you want to analyze. Now all those items that you have itemized. Let me use that word. Permit me to use that word. You have highlighted. Now, since it's difficult for you now to be reporting them one by one, that will not be might be appropriate. That will not be too clean. You know, it might be too cumbersome for what we're talking about. So factor analysis will just compress for you. Rather than say 20 items, you can merge it into 3 items. You can merge into 4 items, which would be grouped in a given cluster based on the algorithm or the factor analysis. You get the argument? So, but don't bother yourself. I use the word algorithm. You don't need to be thinking about how factor analysis is going to do it. That is not your concern. The only concern that you have to think about is factor analysis. Take this as input, go and process it for me, and bring back the result. So when factor analysis now brings back the result, how do you understand what it has done? So the correlation among many items to search for common clusters of variables. So I think you begin to understand. You know, you use some correlation among those items. When I say items, items are those variables you have written out as a part of you know, questions you want to ask your respondents. So when you say items, that's what you'll be thinking about. So it uses correlation among many items to search for common clusters of variables. You know that. Common clusters to generate clusters. As we are seated here, do you know we are seated in different clusters? How many clusters are we in this class as we are? 5. 5. Okay, can you tell us? Good. Show us your 4. Good. You're excluding me. Have I not seen this group? So we can also say that this is a cluster. We can also say that that's another cluster. And you can also say that I am also a standalone cluster or an outlier. 3 cluster. Abi, we can also say this easily, so easily because of what? Because of proximity, nearness to one another. In fact, that's what we use in clustering, in machine learning. That's what we use to know, to calculate clusters. You look at the nearness, the closeness, the proximity from one item to the other. So easily you can say that this is a cluster, that's another cluster, this is another cluster here, and this is another cluster standing alone, this is another cluster standing alone. So the factor analysis will take that and will group those items into clusters of variables, which will be useful. So the aim is to identify relatively homogeneous groups of variables called factors. So at the end of the day, factor analysis wants to assist you to get some sense from your items and then bring out salient factors. You know what we mean? Salient factors which you can zero in on and say, okay, for this particular thing we want to find out, we can categorically say that we have 3 factors which are largely finance. What is again? I'm just using an example, which are largely finance, personal behavior, and what is again? Another thing, another factor. No. It's not going to be. It is. You're not getting it. Since you have mentioned, it shows that you don't understand it yet. Height could be an item that have been combined by a number of items. That have been combined with other items to come out. We're going to begin to see. Don't worry, we will get there. To come out with another factor. That is just okay. Let's move on. Don't worry. So aims to identify relative homogeneous groups. Homogeneous means same group that have the same characteristics, uniform characteristics. So that at the end of the day, we can say that this guy and this guy, they have some things in common, and then I can group them together. Do you get that? Are you getting that? It's like somebody who is crippled, physically challenged, whose eyes cannot see very well. You can say that somebody whose eyes cannot see very well may likely have also the possibility of not speaking well as well. May also not, there's also a likelihood that it may come from a poor family. You know what I mean? Also, yes. So factor analysis is trying to say all of these guys now, we can call them one single factor. Pull all of these together, and they will say all of these can be referred to as a single factor. So that single factor will now derive its name from here. Because the factor is latent, you don't know it. And that's the beauty of factor analysis. You want to bring out some factors from a number of questions, from a number of items, which you do not have their names. You don't have an idea about their names. And that will be the contribution of your work. That at the end of the day, what are you coming out with? So makes empirical testing of theoretical data structures possible. It's also going to, empirical has to do with all this your quantitative study. Because at the end of the day, you have gone to the field, you are back, you have coded your work, now you have analyzed it. So the essence is to give you in quantitative figures, quantitative data, you know. But then this is going to, because normally when you are doing your work, there must be a theoretical background. I hope you know that. For masters, but it's also important that you have some theoretical background for your masters, for your work. But if you're on a PhD, it is extremely compulsory for you to have theoretical background. So that is where your work will definitely flow. Look at the argument. There must be, they believe that there is nothing on this surface of the earth that has happened, or any research you want to conduct, that you do not have a theory that have existed that will be related to that work. So as you get the theory, I'm just coming from a seminar, I told you, of computer department. And somebody was making mention of, he just mentioned those theories without talking about the theories. You have to talk about each element of your theory, and it must also flow from the beginning. Let me tell you, this is the way theses are read. They have to check, they will check your title. The title, then what theoretical background do you use for your work? It's not just using any theoretical background, it must flow also with your data by the time you get there. It must be, the language must be in your data, in your analysis. And at the end of the day, it must come out in your results. So there must be a flow. There is always a flow. Once there is a disconnect, your thesis cannot scale through. So there must be a flow. So note that today. So is saying that factor analysis will assist in making empirical testing of theoretical structures. Theories that we have used for your work, that this is what they say that will happen when people do this. This is what will happen. Maybe that's what the particular theory is saying. But at the end of the day, you have now gone to the field and you are now testing. Factor analysis is now telling you that when we match these items together, it will definitely give you another. So it is from your theories, from your literature search, that you will have information about those items you can pull together. At the end of the day as well, it is from your literature search and a glimpse from the combination of the types of items that will give you a hint about what name to give to your latent variable. We call it latent variable because it does not have any name from the beginning. So don't worry, we understand it better as we move on. So variables that significantly correlate with each other are assumed to measure the same thing. We have said this a number of times in class. Do you agree with me with that statement? That when variables correlate maximally, fully, what do we call that? I want you to encourage me. Look at that statement now. Variables that significantly correlate with each other are assumed to measure same thing. And to what extent? We discussed very well in regression. It is usually within this, within this neighborhood correlation. True or false? And the threshold of correlation. You're not telling me. You're not telling me.
Zero is no correlation.
Uh-huh.
One is perfect.
Uh-huh. One is perfect correlation, but is that what we desire?
No.
Uh-huh. So when it is perfect, what is that saying? Or when it is moving towards perfection, when it is more than a given threshold, it's telling us that what? And there's a name for it. When two variables, when they highly correlate. What about when multiple variables are highly correlated? Hey, collinearity. That word more than 20 times in this class. So it's saying that variables that significantly correlate with each other are assumed to measure the same thing. Then the idea then is to identify the common thing that correlated variables are measuring. In factor analysis, your variables must correlate. There must be relationship. You know, it's a different thing now. We don't mind too much when your variables or your items when they have when they are highly correlated. In fact, it is our joy because it's showing that they have things in common. Because at the end of the day, we want to match those some of them together that have same quality or same features together to be able to say that, oh, these 5 items, we are now representing them as one. So that when you use one name, it can cover the 5 items. That's what factor analysis wants to do. So look at this correlation. We have about 6 correlations there. Correlation x1 to x1 and all of that. You will see that x1 correlates very well, highly with x2. That's 0.65. And x1 also correlates, x2 also correlates with x3. x2 and x3. That's the high correlation of that. And what is that figure? If you are looking at this from your end, no, that's 0.73. What about the correlation of x3 and x4? 0.77. Can you see that? So all of that in a regression, we will reject these ones because they are highly correlated. But factor analysis will be happy that it's happening this way. What am I saying? This is acceptable in factor analysis, but not in regression. Good. This is expected. They must be correlated. Your items must be correlated. The main purpose of factor analysis are to reduce data to a smaller set of underlying summary variables, like I said, and then to explore and empirically test the theoretical underlying structure of a phenomenon. Just like I gave an example the other time. Another example here is our attitude towards contraceptive use, a unidimensional or multidimensional construct. Simplify data by unearthing a smaller number of underlying latent variables. You want to dig deep to summarize your items into smaller number of latent, you can eliminate them. Then unclear variables, when some variables are not clear as well, you can see it at a glance. And then irrelevant, there are some variables that we used, especially when we are carrying out our research, when we are going to the field, that we have included in our questionnaire, that may not be necessary for your purpose. So factor analysis will see that based on the responses and will knock it out. And we're going to see how factor analysis is going to begin to eliminate that. We're going to see it as we move on. So this is the conceptual framework, an example of your conceptual framework from your research. You are saying that there are 11 items here, and factor analysis has been used at the end of the day to compress them to how many? To 3. Meaning that the first 4 items L1, L2, L3, L4, have been grouped as 1, and that is named as factor 1. So another one, L5, L6, L7, it is not just by inspection. The grouping is not by inspection. The grouping is by a factor. Yeah. So it's by inspection. So and then that one is also grouped. It's called factor 2. Give them a name. Thank you. It's not just height size. There must be something about the height. There must be something about the height. It could be the height of respondents or the size of respondents as well. That's something like size. Size, how do you want to measure size? Thank you. Weight, things like that. So those are items which are apparently coming from your questionnaire. So that is the structure of conceptual model. So the conceptual model here is saying that we have 11 items which have been previously grouped to go into these latent variables. Latent variable factor 1, factor 2, factor 3. Just like we have names underneath for all these items L1, L2, L3 that we have mentioned now, you must also create a name for this factor 1, factor 2, factor 3. Thank you, that will cover them. And that's why we call it latent variable. So it is your creation. It is your thinking that will give them that name. In the beginning now, God created the heaven and the earth, is that not? Yes. Who was the person that was giving every other thing the names? So Adam was giving them. So God has also made you an Adam of your research. You are using factor analysis. You know what I mean? So it is you that will now say, wait a minute, let me give it a name like, but then you must be equipped before you can give it a name. You won't just say, let me which name should I give you? I think I like history. Let me use Usman Dafodio. No. It must be related based on your work, based on your search of literature. Do you get it now? That is why you cannot escape any aspect of your research work. If you escape any aspect of your research work, it will definitely show at the end of the day. Do you get it? So you must be grounded in literature, relevant literature for your work. If you just come here and say conceptual, what do you call it? Conceptual presentation, first seminar, you may escape, it may leave you. Just allow you to escape first seminar. And just keep that literature review and you move to the third one. You know that's what people normally do. They just say, literature review. They won't say anything. They may even say literature review. We're going to be using this theory, this other theory, this other theory. They won't say anything about the theory, and they just gloss over it. And now the next thing is our methodology. Methodology, we use this methodology to achieve this objective and things like that. Fine. But you think that you have escaped literature search, but then you're still going to come back to it. Because we definitely need it. So it is important for you not just download anything and then have like 2 million papers that you cannot understand. Let me give you my secret. What I normally do is, once I have any title I want to work on, I look for a similar paper. Download that paper from top journals, not this local journal anywhere in Kenya or in Nigeria. Not 1 month journal. There are some journals that when they accept it today, they will publish it tomorrow. It is not those ones. Look for quality. That is where you're going to get ideas for your work. When you see us come here, we tell you a number of things. It is because we have spent some time reading quality journals. So get 1 or 2 quality journals, get it downloaded, and let it be your working Bible. What do I mean? Get it printed. Forget about all these soft copy. Get it printed. Wherever you go with it. As you are reading it, you'll be making your marks. Some of the things you are going to be needing for your work, you will be seeing them there. So as you see it, you just make a note. Don't go to your computer yet, so don't begin anything yet. Make a note here. Read further again. You will underline, oh, this will be useful. Make a note. Read further again. Look at the methodology. Look at the way they have done it. You can replicate the same for your own as well. So that's the secret of doing quality work. Now, what am I saying? If you are doing factor analysis, before you go to your feed for the field work, before you even do your questionnaire, you also need to read. You won't just be bringing the questions from your head. No, you can do that, but then there's a limit to the amount of questions you can bring from your head, because that is not maybe you have not done any research in that line before. You can also get some of these sense, some of these hints from literatures. You can get some few factors that will be relevant in a paper. Note that. You also look for another paper again. You get some other relevant factors as well. You bring them together. So as we harness all those factors together, your work will become robust. When somebody else is seeing it, you have already grabbed knowledge from here, from there, from here, and you put everything together. So when they get your work, it is a more comprehensive one than what have existed in literature. So that is, these are some of your contributions. Now let's move on. What are we saying? You already know what this is telling us, and that is what factor analysis will do for you. That's the major work of factor analysis. So look at this model as well. There are about two models, model with cross-loading, and we have another model without cross-loading. What do we mean by cross-loading? When you have item 1, item 2, all of that pointing to factor 1. There is no one that is crossing from anywhere. You have item 3, 4, 5, and 6. 3, 4, 5, and 6. 3, 4, 5 pointing to factor 1 as well. But another item 6 is going to factor 1. Look at the second one. You find out that there are two nodes coming out of item 1 to factor 1. I'm looking at the one to my right now. But ordinarily, the second one, looking at the second one the second model to my right, also to your right. Item 1, two legs, if you can use that word, are coming out. One going to factor 1, the other one going to factor 2. So that's why it's crossing, because 2 can relate to 2 major factors. So that is that. The same can also happen in your work. Fine, it's good. Then we have 2 major types. In fact, there are even more of factor analysis. But the major ones we're going to be talking about is the exploratory factor analysis, which is called EFA, and confirmatory factor analysis. EFA explores and summarizes underlying correlational structure in a data set. Like I said, it makes use of the relationship among the elements, the items. But confirmatory, it tests the correlational structure of a data set against hypothesized structure. Don't worry about that, those big grammar. Because initially, you will have hypothesized from your conceptual model that this is what you want your work to achieve. This is what we are assuming, which you want to test with your data. And what is that assumption? I think you must have learned about hypothesis formulation. Yes. Good. Abi? Fantastic. So your work must have hypothesis, especially with factor analysis, that women use computers more than their male counterparts, or female users or females use computer more than their male counterparts. That's an hypothesis. Could be an alternative hypothesis. What do you think will be the corresponding null hypothesis for that? And what is the converse? Mathematician, tell us the converse now. Yes, it could be that. You must understand how to formulate hypothesis. I think you must have learned that yesterday. What is another way of framing it? Thank you. That's another way. To frame it. So you must. So in your work, you must formulate your hypothesis at the beginning. I may be able to share one of my research output for you, maybe on our platform, and then you can see the way I've worded the hypothesis and the way I've achieved it in the results. Because at the end of the day, you must achieve the hypothesis you have set. Then confirmatory factor analysis, test the correlation. That's what I have said. So that's what that will do for you. Now, assumption of factor analysis. Like we always have assumptions for all analytical tools. Do you still remember the assumptions for regression? True or false? Do you still remember? No, yes. But you also remember that it's not a single regression that we have. We talked extensively on about 2 or 3 of them, and you also have the rest in your notes, which I posted about 2 months ago. They have similar assumptions, but not most of the time. Though they have similar assumptions, but they are not same. So you must know the assumption for linear. You must also know the assumption for binary. So it is very important. Now, these are the assumptions for factor analysis. Level of measurement. All items must be ratio or metric data, or at least Likert type scale. What do you think this is saying? Levels of measurement, because you must measure your items, your variables. So how do you measure this? How do you ensure that this is in line with what is required? Yes, factor analysis is telling you that the requirement for factor analysis is that your items must be ratio or metric. Or what's another name for that? If you understand what it's saying.
Length.
How do you measure? When you say length, how do you?
It must be continuous. Not discrete or continuous.
What is saying that it must be numeric? Numeric. It can't be continuous. It must be numeric. And that is why your Likert type scale is usually 5 type, 7, and I think it's always a well, I know of 5 and 7 Likert type scale. So what I say is, when you go to the Likert type scale, what it is saying is that give me an example. Thank you. Strongly agree. Agree. It's also possible, but most of the time, to be agree. This is the most, this is what we need most. Although, for me, I still have argument about this. But this is not the time for us to discuss that. So I was just trying to let you see what a Likert type scale is. Because at the end of the day, by the time you code it in your SPSS, R or whatever, or theta, it's going to give you this 5 now represent the strongly agreed, which is numeric in nature. You get it? So you will not ask a question, and then you will not ask the question of do you use internet? What would that be? What do we call this? Eh? You have to be good with some of these names, these terms. That's what you need to use. Because by the time you are presenting, these are the terms you should be using. We are trained to be masters of, you want to get a master or a PhD, to be a master of that thing. Dichotomous. It is when you are using these words that they will respect your presentation anywhere, anytime, any day. So dichotomous. That's not what you want to do, is that not? So, or a question like write or suggest ways by which we can improve on the technology. What do you call this? Eh? Open-ended. So this is open-ended. So by the time you now want to do your analysis, you say, okay, let me use factor analysis to bring this in, to bring this in. Is that correct? No. So from day one, before you go to the field, as you are even writing your questionnaire, you must understand this. So you must know that for if you intend to use factor analysis to achieve a particular hypothesis or a particular objective, then your questions must be in items, and you must carry something like this. Eh? I told you it's the same thing. It's saying it is numeric. So next one, another assumption is that it must be multivariate normal. We have talked about normality in this class. True or false? So your items must be normal. Your variables must be normal. What is normality of a variable? What do we say normality of a variable is? When do we say your variable is normal? This will be about a third or 1 million times of like this thing here. When there is no deviation to the left or to the right. When there is no skewness. When your variable does not skew either to the left or to the right. I also remember I talked about cortices. If I were you, as teacher, teach you some of these things.
When u is equal to 0. When u is equal to 0.
Of what?
Of this curve.
Well, for me, I don't know. But if that is what it means, if your mean is equal to 0, not necessarily, within this threshold, if it is within this threshold, there's no skewness. Because if you have a graph like this, do you remember now? Yes. It's showing that this is not normal. The curve is not normal. How do you check that? You check using scatter plots. Especially if you are in for PhD, you need to work. That's why I said to you that you cannot contract your analysis out. If you contract it out, you won't understand it. They may not even understand it. Even if they understand it, you will not understand it. If you do not start from the beginning now to put all these elements together, to force yourself to learn it. You understand? But if you're able to learn it and you understand it, you can stand anywhere and then you would do well. Then what other things here? Absence of outliers. We have talked about these outliers severally as well. It must not have, your items must not have outliers. Then sample size. This is very important. Your sample size that is required must be in such a way that it's large enough to accommodate factor analysis. Some people just have a sample of 100 or 50 cases, and they want to say, oh, we want to use factor analysis. It does not work that way. Some literature will tell you 200, some will tell you 400. But majorly, it must be based on the number of items. It must be a multiple of your items. If you look at this recommendation, number of cases per item should be at least 5 to 1. Do you understand that?
Yes.
Another one is saying larger ratio preferably, or that is preferable, should be between a threshold of 20 and 1. That is, you have 20 cases, you reserve 20 cases for one item. Let me explain. You know what cases are now, have you? Case files. We don't have case files in hospitals. True or false? So my own case file will carry my name, my age, my height, my weight, the size of my tummy, and the size of your tummy. True or false? So which one is bigger? So that's a single case for me, a single case file for me. So also for you. So that's why this way is a case, is another case, another case, another case. 1, 2, 3, 4, 5. So each of your questionnaires are referred to as case. You know, we have so many things within that questionnaire, isn't it? So many items, so many questions. But the questionnaire is a case. So it is saying that if you want to have items now, are the questions for your factor analysis. I mean, like talk about the variables. But this time around, I want to have items. Your question 1 is item 1 under the factor analysis section. You can have other questions, know that. But by the time you are getting to factor analysis question, we call them items. So item 1, that's question 1. Another one, item 2, that's question 2, item 3, and so on and so forth. So in a situation whereby you want to measure 16 items, up to 16. The recommendation is telling us that let this be a ratio of 20 cases per item. So what will now be the sample size of our entire questionnaire? What will now be our sample size for our research? If we have the mind to bring in to measure 16 variables. You agree with me? You get it? Because you are reserving 20 cases for one item. If you have 2 items, another 20 cases will also come for this. 20, 20, 20 up to 16 places. That will give you the minimum of 320 questionnaires. That must be duly completed. Not that must be the number of questionnaires you would send out. Must be the number of cases that you subject factor analysis to. Fully completed. You get it? So in that case, you don't want to go out and distribute only 320 questionnaires, because apparently you know there is a likelihood, a very strong chance that you cannot come back with 100% return rate. True of us. So you want to add to this number as you go to the field. So what am I saying in essence is, if you want to now say, okay, 20 items, your items, the total number of your items should be 20. What should be the recommended number of cases that should be analyzed? They are putting the cat in us. You know the answer within you, but you are giving me a post hoc answer. If I will use that word, that's going to stress. The feed, you won't just say that I want to use factor analysis. Somebody will just come from the feed with 150 whatever respondents. I want to subject it to factor analysis. If you come here, we will tell you it's 0. You go back to the feed. So, but if you are equipped from now, before you get to that point, you already know how to do it, how to calculate. Good. Yeah, the larger the better. You understand? But this is the minimum. At least this is the minimum. If it's more, that's the best way. That's the best thing that is expected, especially with factor analysis. You know. So that is that. So that's very germane, very, very germane, the sample size. Then the factorability, there should be some degree of collinearity, like I said. There must be some degree of collinearity that is expected. So there are some thresholds here. Inter-items correlations, exclude them without a minimum of 0.4 with at least one item. If it is not 0.4, exclude. Then anti-image correlation matrix diagnosis. You can't see this figure offhand until you carry out your what do you call it? Your factor analysis within using your tools. That's when you can then see the anti-image correlation matrix. But it's giving you a threshold here that at least 30% of the off-diagonal coefficient should be less than 0.09. When you run your factor analysis, you'll begin to see all of this. But If you note this threshold, then you will have been equipped before you get there. Then we'll call something measures of sampling adequacies, MSA. These are the terms that an examiner will be expecting you to speak to when you are claiming that you have used factor analysis. If you claim to have used factor analysis and you did not show them your Kaiser-Meyer oil key, KMO, you did not show them Bartlett's test, then they will tell you you have not done anything, because they want to see the threshold. Because the threshold here is telling us that your KMO should be greater than 0.5, and your Bartlett's test of sphericity should be significant. And we already learned what it means to say that, oh, something is significant, true or false, at a given threshold. You remember, we talked about significance. When you say that, oh, this particular thing is correlated and significant, or things like that. I don't want to go into that. When it's significant, at what level? How many levels did we talk about? Eh? Thank you. Is it 90 and 95%? It was 99. Although it's also possible to have 90. Most of the time they have about three from 90%, 95, and 99. But what is this? What do you call it? What's the name? Yes, level of significance. Yes. But then there's another name, because you do know we have a corresponding value again for this one, which could be no. Thank you. So what do you call it? What do you call it? For me, I prefer to write it. Then this is called error level. The error is minimal in this case. When you see it small, that is error. This one is confidence level. We have 90% confidence that this thing is like this. We have 95% confidence that this is like this. We have 99% confidence that the result is significant. But at the same time, if you want to use the error level, we only have 1% error level in the analysis. So let's move on. What's the time? All right. So that is that. Then steps in factor analysis. Number one, you must verify that your assumptions are met. Your assumptions, you must verify that they are met. Then select type of analysis you want to use, and then the method of extraction of Is it EFA exploratory factor analysis or confirmatory factor analysis? And then your method of rotation, is it going to be varimass, orthogonal? We're going to see that and all of that. Then you have to extract your initial solution. Then your initial solution will be guided by a threshold, which we are going to see. By the time you extract, you run your factor analysis, you have to decide the cut points. That, okay, once I have a threshold of 0.4 or 0.5, I will accept that the agent value for this is good to go. We will say it. Then you must determine the number of factors to retain. You have to determine, okay, fine, out of these numbers of these factors, how many do I retain? You have to decide it. But as you decide, you also have to be informed by your output, not just deciding from your head. Although you can have it, you can have a kind of a conception that, okay, fine, if I have 3 to 4 clusters, I will just run with that. But then you have to depend on the output that is coming. Factor analysis will show you the number of factors to accept. In fact, at a glance, scree plot will show you that at a glance. We are going to see it. So then you have to drop items if necessary and repeat steps 3 and 4. In terms of regression, we did something like this. When you are dropping variables, when you are dropping in your analysis, you are dropping variables, you run a model and you drop a number of variables again, maybe 1 or 2, and you run it again. What do we call that? What type of regression is that? You have to encourage me. Because if you don't respond appropriately, then it shows that all the energy I've invested to pour my heart for you for these classes. My class, you don't have to read. If you attend my class, you don't have to go back to read to understand all the things I have taught you. If you have your 100% with me all the time, honestly. But you don't have 1 year.
That was why I was asking for some of these things discussed last week.
But you were there, you witnessed it. So that you have a video, the video is to just play back for you, especially number 1 for those that may not be there, and then number 2 to remind you some few things, not necessarily 100% that you may have forgotten. That's the sense of it. So what's my question? Have you forgotten stepwise regression? Stepwise. Yes, now this backward and forward, whatever that would, I think I demonstrated it also. Backward and forward regression, whereby you can be doing it 1 by 1. When you want to regress like 10 variables, now you can remove them from the back, or you bring them in 1 by 1 and then see the changes. That'll be backward and forward. So I hope you won't, by the time I ask that question in the exam, you won't say that because you have not listened to one video. So then you have to determine, yes, drop items if necessary and repeat 3 and 4. You know the reason why you may have to drop items? When those items seems not to be relevant, then you drop them off. Then name and define your factors. Like I said, I've said so many things about this. You have to be able to give a name, an appropriate name to your extracted factors. Then examine correlations among the factors, then analyze the internal reliability. The analysis of the internal reliability will not be done by you, it will be done by factor analysis, and then you can begin to see the elements. Sample size, minimum sample size, I think we talked about this, 5 cases per item. That's the minimum. I don't even use that. I use a threshold of 20. It must be 20. So if you have 20 items, your what you're going to analyze shouldn't be less than what? 100. So don't tell anybody tell you that. Don't worry, that number of personnel is too much. It's just masters. It's too much. And then you come back and tell us that you want to use factor analysis. You cannot use it now based on this threshold. Based on this, true of us. Is that Ole saying this? No, this is authoritative. All of these things you see here, they are there in literature. You know, they are established in literature. So we are saying here that the sample size of at least 200 cases is preferable, at least. But don't forget, if you're for 200 cases, how many items maximum are you expected to have? Do you get that? Number of items you have, if you want to do 200 cases, must not be more than 10. And usually you don't do 10 items variable, 10 items subject them to. Why do you just have, you know? Because at the end, because at the end of the day, if you say you want to have 10 items, and then at the end you want to come out with that many, maybe 3 groups, how do you now divide 10 into 3? It's also possible because you can have 3, 3, 3, and 4. 3, 3, 4. Yes, your question. For the more, yes.
No, when you try to do questionnaire, typical kind of questionnaire, you have different kind of items.
Yes.
Some will be latent, straightforward.
Okay.
While some others will be format.
Yes.
So what if you have that kind of case, and you also want to do the factor analysis?
Yes.
Is it that you are going to consider these aspects for all cases, both with the dichotomy and
Okay, I get your point. That's why when you are drafting your questionnaire, it must be structured. And when we say structure questionnaire, what we mean is You have three objectives. Objective one, to do this, to do this. Objective two, to do this, to do this. Objective three, to do this, to achieve this. Now, by these objectives will guide the way you draft your questionnaire. So by the time you are drafting your questionnaire, there are some questions that will be relevant to item one. And that is what we want to see when you ask you to present your conceptual seminar. They want to know, are you equipped with how the questions and the tools to achieve objective one? So your objective one, you must know the questions to ask your respondent to achieve objective one. You understand? At the same time, you must also know the type of tool, analytical tool, you want to use to analyze the questions meant to achieve objective one. That must have been in you when you are preparing your first one. So this one may not necessarily be factor analysis, because you have your yes or no, which you want to do. You have you want to know their age, only age, you want to know whether they belong to the academic background, highest one, qualification, which may not be like that. So that may be the combination of those ones, may be what you need to put together to achieve the objective one. So that way you will know that factor analysis is not the right tool to analyze objective one. Then what other alternatives are you left with to analyze the objective one? If these are some of the questions you have to achieve this, then from there you can know that, oh, then this cannot be regression if it is not something that wants to impact on the other. If you want to talk about what is the impact of A on B, you know automatically that is regression. You'll get my arguments. So that's it. Does that satisfy you?
Yes, and now, so the number of questionnaires now depend on the number of questions.
The number of
Because
questions.
if, for instance, now there's two numbers, that is the latent scree,
Mm.
and then I have maybe on that to answer my objective,
Good.
I have 20 items.
Good.
And then I have collected just 300.
You can't collect, so before you collect, you must know what to collect.
So
Not after you have returned, otherwise you go back to the field and play football.
my objective two, I have to make sure corresponds to the assumption.
Thank you.
For it to work.
Thank you. Because there is no amount of number of cases that can be more for regression. There can be more for ANOVA. But it can be few for factor analysis. So you make sure you take your factor analysis. Once you have taken your factor analysis, the rest will fall in place. You get that now? It's just like when you want to carry some things, you exempt female. But when you want to distribute money, they will be saying gender insensitive. They want to collect first. Two of us. So this, like, you must make sure that the place of factor analysis is given a huge place. Is a stakeholder in determining the size of your sample size.
Is it possible to produce more than one set of questions?
Definitely, depending on what is required of your work. But as you do that, that will be more cumbersome, because it's possible for you to bring them together and analyze, but most of the time they will expect you to analyze them separately. But then you can also analyze them together if you have the skill than single questionnaire. Yes. No, you have to still obey the rule. If a pilot study is like a model, a similitude, a prototype of a larger one. So you must ensure that, because at the end of the day, you want to analyze that as well, to give you insights into what you should expect in the final model, in the final analysis. So you must also respect that. I get your point. The point is that would be too expensive. So in that case, that's a very good question. What do you do? What do you do? What do you do? You may just close your eyes to the analysis of the pilot study for factor analysis. The only sense you can bring out from there is that by the time you do your pilot study, you will just know that what you're expecting is to see whether people understand the way you have structured the question. That will be the only thing you'll be gaining for the part of factor analysis. Because some people at the end of the day, when they come back from pilots, they want to analyze and see from afar the likely what they should expect at the end of the day. That's why you do pilot study. You get that? But a safer way and a cheaper way is to still limit your numbers. And then, because you can't say, because you want to do pilot test, let me do 200 questionnaire, and then come back again and go and do another 200. You are repeating the same thing. So let's move on. So extraction solutions. I'm not going to dwell too much here because of our time, but they are very simple. Use principal components and all the items you have identified. Note the number of factors extracted. Like I said, then examine the agent values and factor loading. Agent values are values you will see like correlational values, but they are currently called agent values in mathematics. When you do your factor analysis, it will generate some values for you for each of the items, depending on what is found within the items when you mix them together. So, but then these agent values and the factor loadings would inform the cost points you are going to set to determine which one is relevant, which one. And so, okay, from 0.5 and above, count it as significant. Note which items load strongly on which factor. This is very important. In fact, this will give you a glimpse of how to christen your factor. When you see a factor talking about finance, and it is very high among an item rather, like I said, we have many items, item 1, item 2, item 3, all of them coming together to form a factor. And this particular item 2 is having like 0.7. This one is having like 0.4. Less than 0.5. If that is your minimum threshold. And this is saying 0.52. Which one is the highest? The second item, 0.7. So you look at the name of this one. What is this saying? Is this guy talking about finance? Then you can, from there, get a glimpse that why don't we call this finances? So that factor will not be within the neighborhood of finance. But then you find out that by the time you pick the item 1 is also related to finance. It may have to do with, let me give you an item. Maybe you want to ask a question about whether they have cooperative in their cooperative association in the market. Say for example, you go to computer village, you're asking them, does your business belong to any cooperative association? Yes or no, or whatever, or maybe like that, or to what extent? Then what percentage of your income do you put on something? Is that also talking about money? So from there you can infer that, oh, this is likely, all of these groups are likely to be called things that have to do with finance, and then you can name it that way. So because 75 million is greater than 25 million, true of us. But that's even correct. So what that is saying is 75% of the variance is represented in your model, which means that at least the remaining 25% is what you have not covered, which is still good enough. You understand? So it's saying that the total variance to be explained must equals the number of items in the model, which means that we are doing. If that question will be relevant, subject some of them there. Otherwise, create some other questions that will have five point like a scale, strongly agree and things like that, and put some hypothetical data to experiment, so that all these grammar, you can begin to see some of these thresholds as you have your output from your SPSS. And how do you go about it? It's very simple. Just go to your menu that will show maybe analyze, and go to factor reduction. When you see factor reduction, it will drop another menu for you, and it will show you factor analysis. Once you click on factor analysis, it will open a dialog box where you just have to bring in all the values, all the items, not all the total questions, or just all selected items that carries like a type. Don't forget, bring all your items, maybe 16, 20, 10, I don't know the number. Bring them into that box and click OK. Once you click OK, it will generate all of these things for you. You will see KMO, you will see KMO, you will see Bartlett's test, you will see everything to be generated for you. Then it also depends on, within that, before you click your OK, click options, something like options. And there you will see scree plots. Check scree plots, because that will give you the graph. More acceptable. That when you have an agent value of 0.4 and above, it is acceptable. You can also decide that I don't want 0.4 if you have number of too many factors that are generated for you and you want to reduce it. So you can raise your cut points and tell the computer and say, let the minimum cut point be 0.5, and you can generate your model again. It's there. You will see a column that will be blinking where you can put the values. So commonality and uniqueness, and then so this is script plot I talked about. Carttell script plot. Where does it drop off? You have to look at the script plot. Where does it drop off? Like, if you draw it, it's so obvious now. But if you have computed it, the script plot would give us an insight that you have actually run the analysis, and that's the script plot of your graph, as you see that. Can you see the script plot? So the agent values are on the left, and so that's how to determine it. Can you see that? You can easily cut it off from that red line, because the rest, they look like but on another time, if you have other factors which you want to still talk about, maybe emanating from your theory, maybe you have about 4 factors that they're talking about, you can still manage another factor here. You can manage the 4th one and switch your red line below that last one. Do you get it? To accommodate 4 factors. But if you look at the gap, you will see that at the end of the day, the contribution of that particular factor will not be large, will not be much. If you look at this large gap between the first one on top and the next one, you can agree with me that that is likely going to come out if at the end of the day, the total you are having is 75% million. This guy must have taken about 50%. Speaking about 50%. So the next one may be 30%, the next one may be 20%. Can you see what I'm saying? So that's the way to do it. So I think refine model and rerun. If that model does not satisfy what you want, that is what I have done also from the script plot. You can refine it. You can go back and knock out some unnecessary items and then rerun your code. Then are there variables that do not load significantly on any factor? You can also check those variables by inspecting the values. Then consider dropping, like I said, variables as necessary. And then rerun the analysis and then obtain your results. Do some rotations. The rotation is like you want to permutate and combine. Just experiment. Just also experiment with some rotations and then see which one will give you the best value. And that's why it's composed experiment, because you are not losing anything. Once it does not give you what you want, go back to where you're coming from. Test another combinations, and then from there you can then decide. Because what you should be looking out for is the percentage variance. if it's increasing and it's giving you what you want. Because if you can do some combinations and you have like 50%, you don't have to go for that. But if that is the maximum you have from all the combinations, then you have to run with that. So factors, that's what I said. You'll be rotating it. It's not, you are not going to be using your hand to rotate apparently. The tool is also there to look at which kind of rotation you want to use. Is it orthogonal? Is it varimax? And all of that. And this is what we have here. Orthogonal minimizes factor covariation, produces factors which are independent to each other. You know, there are different algorithms or models which you can use to check which one will fit, will suit your data. Because if I use a particular one for my data, does not necessarily mean that that is what you should use for your data. No. What you have to be on the lookout to look at the output and see that whether the output is what you expect or not. We also have oblique, we also have varimax, and a few others. So, and then these are the thresholds to check, to examine correlation between factors in oblique. If it is greater than 0.32, then you can go with. Okay, there are a number of conditions to check that. So this is more or less like summarizing what we have done. You want to identify the items that load most significantly on each of our 3 factors, and then what items load most significantly on this factor on each. All you still have to confirm using regression. That is why, like I told you, regression is an analysis, is an analytical tool that will meet everywhere you go. So as you output your factor analysis, behind the scene as well, you have to correlate your factors. You know that you have already extracted some factors. So on your table, on your data table, data will have been generated for you. It will have stored it back in your data, in the output variable. Under factor 1, factor 2, factor 3, factor whatever, it will have put all those variables there. So now go back and regress and do a form of correlation, which we, this is recommending. See whether those factors correlate. At the same time, you now carry out a regression as well to finalize that those significance are not just by chance. You get it? To confirm whether those factors. Yes. Is it some questions to ask when you're talking about factor analysis, and that's the essence of this class.
So in terms of